Starting streaming. Uploading. Have an orange progress bar on my upload status, but
I see it on my iPad. It's in Bytes Livestream.
is it displaying the image?
It's displaying the image, yeah. Bits and bytes with the moon.
Awesome. Good enough. Yep, that was the quick 2-minute thing I threw together.
Maybe later we can try and come up with something a little more, clever.
Well, yeah, but hey, what do you expect
For now.
when you have to do something like the moment you're going live?
Yeah, that's more than sufficient.
Yes.
I still haven't come up with a logo for Open Intel, and I've had the site for this year will make 10 years. So I'm a little procrastinating at that too.
Yeah. Okay, and welcome to another night of randomness, of technology and goofing off and drinking beer or coffee. Been a while.
Welcome, everybody.
But we're back, finally. We haven't dropped off the map completely.
Yeah, just, periodic times of us not doing it because things just don't work out.
Pretty much, yeah.
Maybe one of these days we'll both be in a position where we can actually have these as regularly scheduled, planned events rather than just going, hey, you want to do a webcast tonight?
Yeah, it kind of takes the spontaneity out of it and part of the fun.
True.
So, yeah. So you have a few articles to chat about this week, and I have one as well. So shall we talk about a new type of computer that's being developed?
Certainly.
Okay.
I have not read about this yet, so I'm looking forward to learning about it.
Good deal. So there is a problem, 2018 with Spectre and all of those vulnerabilities?
Yeah, the side channel attacks for processors.
Yeah.
For speculative execution and that kind of thing.
Yeah. So the root cause of that was from a few instruction sets that were buried in the code or buried in the processor that nobody really knew about. It wasn't really documented. The manufacturer, Intel, didn't really say what these did or any of that. So that really kind of spurred upon a new kind of movement. Raspberry Pi has been working on this, a concept called open computing, where you have an open operating system. The code is available for anybody to look at, for any research team to dig through, try to find issues with. But there's no hardware that was open that provided the same opportunities. ARM or Raspberry Pi was trying to work on that, but their chip, their main CPU, was still closed. And that was a limitation of the manufacturer.
Yeah.
So there's an organization pushed by AMD, I think Microsoft, Google, a bunch of big companies are funding this initiative to make an ARM-based computer or ARM-based CPU that is truly open. The manufacturing process is open. The instruction set is open and published, and anybody can go and contribute and recommend ideas or suggestions or anything. No guarantee it'll be approved, but anybody is free to do that because it's open.
Yeah.
So, for the longest time, while it was being developed, it was a theory. Like they had chips, but it hadn't quite caught on yet. But now I saw Hackaday, which is a blog that does fun little things. They got their hands on one of the early prototype full computers that is running this processor. And I was chatting with some people in the group that I play with, they thought it was a nice idea, but it's just a hobby device right now. It's like the Raspberry Pi can't do a whole lot. Like it's great for home automation, small little projects like robotics, things like that. But you're not going to play Fortnite on those processors anytime soon. And that's a problem. So this company, one of their ideas is to be able to make a full desktop replacement running the ARM, this ARM chip. And do you know anything about ARM versus x86?
I know they're different architectures, but I haven't really studied as to what exactly the differences are.
Yeah.
I know ARM is getting increasingly more powerful just because that's what most like cell phones and stuff like that have them in are usually ARM chips.
Mm-hmm. Yeah, so the x86 stack, the instruction set, it has something like 100 or 200, I don't know the exact number, instructions that are hard-coded on the die. And that is the machine, if you give it this command, it will execute, it will do this job. And there are hundreds of them. And it's just too many possibilities for people to document exactly how it's going to work, especially since it's not even documented in the first place. Plus, that many instructions on a single chip is excessive. The most, generally speaking, most computers only need a handful of instructions to be able to run day-to-day applications. And that's where ARM came into place. ARM is based on a RISC type idea, which is a reduced instruction set.
Oh, okay.
Yeah.
Kind of like how GPUs are from having a much smaller instruction set, which is why they're so much better for like cryptocurrency mining and password cracking.
Exactly. They have a small, limited amount of instructions that they can do, but because of that, it can do those instructions very, very quickly because you can dedicate more die space to those instructions. So instead of being able to run like 8 threads parallel, you can run 80 threads parallel of that operation.
Wow.
So, or conversely, for phones, you can just make a couple threads and make it little teeny tiny and use almost no power whatsoever. So there are two possibilities that you can go here.
Okay. Yeah, I was wondering what they would be like from a performance standpoint because that was the big problem.
Oh. You dropped out for a second. I lost your audio completely. Well, that's not good. How did I lose your audio? Go ahead and say something again. Yay. Nope. Technical difficulties. Anything? Nope. Still nothing. Well, that's weird. Let's try to redial you and see if it works. Please stand by. Disconnecting call. Not call public. Video call. There we go. Nope.
How about now?
Oh, hey, there we go. That's much better. Okay.
Okay.
Oh yeah, evidently my earbuds just decided to kamikaze themselves. So no idea what happened there because I was in the middle of talking and I don't remember what I was talking about. And
Yeah.
then at first I thought I couldn't hear you, and I thought you were somehow muted, and evidently it was me.
Yep, it was you.
So yeah, technical difficulties.
That's okay. Part of the fun of being live and impromptu. Yep. Yeah, so we were talking about ARM before he dropped off. And yeah, there are two ways. You can either go with a power efficient, tiny CPU, or you can load up more cores, more threads onto it, and be as powerful. So
yeah, that was the one thing I was trying to talk about. I don't know how much of it actually got through before my earbuds died. But that was kind of my question from a performance standpoint, was how much of an impact like going that direction is, because I know the big problem with the speculative execution vulnerability is if you actually patched that with the microcode on the hardware, it had a gargantuan hit to performance. Like it was sometimes 40% decrease in performance from the CPU, which if you're running some sort of cloud service or having a few different hosts with a crap ton of VMs, you're facing some serious, like whether or not you have an N+1 type situation, or whether you barely even have enough hardware to even run all your core infrastructure. So
right.
There was I'm sure a lot of places that are smaller that couldn't afford the extra hardware that had to either make the decision of patch this and shut down non-critical systems, or roll with it and accept the risk and hope that nothing bad happens.
Yeah. But in a way, that's kind of Intel's fault for trying to load more than that chip could actually handle.
Yeah.
In reality. So, and yeah, they won't support speculative execution, to my knowledge. Although maybe that's something that they've built into this chip. I haven't read all of the instruction sets that are being developed on it. But they might be working on something like that because they are trying to break into the desktop and server model. Nope. Where'd it go? There. I lost my... Oh, there's my Firefox. Okay. So the Hackaday thing, they got their hands on an actual system that's running this new Risc-V architecture, this Risc-V CPU. And it's, a small computer. It's this particular model. Let's see what we can find. It has, it's running their U540 silicon on chip, 28 nanometer process, 8 gigs of DDR4 memory, 32 megs of flash for storage. It has, you can get an expansion board that gives you all of the standard interfaces that you would expect, including a PCIe 16 by slot. Specifications. Thank you. 24 lane PCIe Southgate, 1 PCI 1 by, 1 PCI 16 by for graphics cards, so you can actually load up a full graphics card onto this board.
Nice.
An M2 SSD connector, a SATA connector, HDMI connector, an MMC flash slot, a micro SD slot, USB 2, I think. Maybe 3, I'm not sure. 16 slots of DDR4, if I'm reading that right. And it still has the GPIO, as you'd expect. And as such, everything is published, so you can find the full specifications of everything. And that's the expansion board. This is basically the main board that would go with this processor, and then the processor would fit in this little slot to the right of the device, as illustrated here. So this is where they have attached the new ARM processor and its core components, like system memory and a few things like that, on that sister card. And then the main board underneath contains your PCIe 1 by, your PCIe 16 by, all of your headers that you need, which will effectively turn it into a full computer.
Nice.
and they're shipping now-ish 2 pre-orders. I don't know.
I still haven't even picked up a Raspberry Pi or any Arduino stuff, so that's kind of a hobbyist area I just haven't really gotten into yet.
Yeah. Now, since this is an early access prototype board, it's a little salty for price. It's going to cost you around $4,000 to buy.
Okay, yeah, I definitely will not be messing around with that anytime soon.
Yeah. But these are some of the first off the assembly line. So we can expect that cost to drop significantly when they start nailing down the manufacturing process and they start getting actual orders in from manufacturers. But the cool thing is they have a device that's running it. Like, they have a computer now that you can load up a full Linux distro. You can run whatever you want. I'm sure it runs Steam on it. And you can have a graphics card, so things are going to be interesting.
Yeah. If nothing else, this thing actually being functional and depending on how well it performs may actually open like Intel and AMD's eyes to maybe some different ways of doing things.
Well, so AMD is actually on board with this. And
okay.
They are working on the Risc-V architecture, and they're building their own custom chips based on the specification that's also open source, because they want to drop this onto their hard drives. So they want to drop the proprietary SSD controller off of hard drives and replace it with one of these Risc-V processors that is open, and it's going to be capable of running, faster operations.
Yeah.
Plus, it's open source, so less chance of shady things happening. Because even a hard drive is a self-contained computer. It has a processor, it has memory, it has code running on it. It's a computer. And any computer is at risk for vulnerability.
Yep.
Yeah. And the company behind this is called Sci5. SIFIVE. Hence, Risc-V, Sci5. Yeah.
Makes sense.
Yeah.
So what does RISC stand for? Because I'm assuming it stands for something.
Reduced Instruction Set Computer? I think.
Makes sense. I like their little graphic as you scroll, their little parallax type thing they did.
Yeah. Let's see what Wikipedia has. Yeah, Reduced Instruction Set Computer. Yeah.
Be very interesting. Maybe it'll be affordable by the time that I actually want to get into start playing around with that kind of stuff.
Possibly. I'm expecting it. If I had to guess, I'd say the cost would be dropped by half, or even 75% by the end of the year. So.
Yeah.
And it's nothing new. They've been developed alongside x86. Actually, earlier than x86. Yeah, computers from the 1970s and 60s and 70s have been RISC-based architectures. The modern concept dates to the 80s. So,
okay.
So yeah, I am excited to see Intel's x86 instruction set go by the wayside in favor of a much simpler, smaller subset.
Yeah. Well, like you said, by reducing those instruction sets, you actually gain performance improvements. So maybe that'll make up for the fact of not doing like speculative execution.
Right.
Because the whole idea behind doing that was trying to predict the kind of choices that a program or application was going to make it so much faster. And then the whole problem was the branch that died off from the decision you didn't make was supposed to have just died off, but the Spectre and Meltdown vulnerabilities proved that that branch that died off could still execute code, and that was where the whole problem arose.
Yep, exactly.
So yeah, it'd be interesting to see how that works out.
Let's see. Found a post on Hacker Noon. Spectre Meltdown, 90% of the server was hit. 4 4 to 30% workload. Yada, yada, yada. Oh, it doesn't say much of anything. Yeah, somewhere there's a post about the exact instruction sets that were different. And it looks like the bit size of the memory bit, execution bit is 32, 64, and 128 for Risc-V.
Nice.
So that could be cool. Let's see, just trying to find. They also have their .org site, but whatever. Yeah, so let's see. No, come back, Platinum Partners. Oh, whatever. There's Berkeley, Google, Marvell, Microchip, Micron, NVIDIA is on board, Qualcomm, Samsung.
Well, of course, Samsung's going to want a part of that.
Oh, yeah. Western Digital, Bitmain. I wonder why they would be on board. Blockstream. There's another Ant-based protocol up there. A bunch of universities. It's always nice to see.
Yeah.
Cryptape. Okay. But humorously enough, I don't see Intel on here. I guess I shouldn't be surprised.
No, I'm not. I'm a little surprised AMD is, but...
Yeah. Well, I don't see AMD listed in the Platinum or Gold member list. But they're working
they're probably kind of waiting to see how everything turns out before they invest too much.
Well, what I read is that they are actually building their own chip based off the Risc-V architecture.
Gotcha.
Specifically for storage. Or is that Western Digital? Fuck, it's one or the other.
Probably Western Digital. I can see them
makes
doing
sense.
that from a storage perspective.
Yeah. Yep, no mention of AMD, so, yep.
Yeah, I imagine them and Intel are going to probably, probably hold out and try and wait and see what's going to happen, or try and come up with their own replacement to compete with this, maybe even eventually.
Well, they'll have to. Plus
Yeah.
the fact that it's open, they have that option. They can grab the schematics, start making their own chips. So, because the company behind it is a non-for-profit organization.
Yep.
So they really don't care if other people start making their own chips, because more people using it, the better.
Yep.
Much like the internet. Internet's a non-commercial, technically military, but venture that the more people using that protocol, the better. So.
Yep.
So that's all of the computing fun that I had for the week. Shall we get into the security articles that you had found?
Sure. So we didn't have nearly as much excitement really happening this week. We did have some excitement for a gargantuan, I'm using that word a lot tonight, vulnerability from the previous week that is now patched, or at least there's a patch available for it. But we'll talk about that later. But one of the first things that kind of came up this week was a weird phishing campaign that uses links with almost 1,000 characters. So normally when you hover over a link, it's, obviously you can looking at the main domain that's actually being referenced to see if it's going where you think it's going. And sometimes you have some query parameters at the end of that for, identifying if it's like a password reset link to, your account, or like an account token or something of that nature. But in this case, evidently they were just trying to obscure it with as much obfuscation as possible, because it is complete and total gibberish garbage. If Charlie scrolls down enough to where we get to the red block of text, yeah, it's just ridiculous. And there's actually somebody else that found one that was like 991 characters long too. So there's evidently a few of these campaigns going around with a few random URLs that are just insanely long for no apparent reason. Kind of makes me wonder what the maximum length a URL string can be.
1024.
1024? Okay.
It's not a hard set from any standard. Like, I think the standard is like thousands upon thousands, but most browsers will refuse to go to a link that's more than 1024 long.
Okay.
And
Good
that's
to know.
just due to absurdity. Like, at no point in time.
So you don't have to deal with this.
Yeah. You should not have a 16,000 character long URL. While technically you could, you shouldn't.
Yeah.
Yeah.
There's no rational explanation for doing so.
Yeah.
Anything that's that large of a section of text, use as part of a post, not as part of a get.
Yep. And that's kind of a rule of thumb as well when you're building a web application, is how do you determine if it should be a get or a post? And part of that goes into, well, what's the size of the data that you're pushing? Is it, just an ID of something, or is it this entire giant object that's a megabyte in size? Well, use a post. Yep. But this brings me back to one of my issues with Outlook. The Outlook client. Is that called Outlook?
Yeah.
Okay.
Yeah, Exchange is the web server, or the email server. Outlook is the client.
Okay. The last time I knew, Outlook had a problem that I consider a problem, that it doesn't really show you the URL. Like,
as far as I know, it does. There are ways you can set it up to where it will actually like translate it out and not actually make it a link.
Okay.
It'll actually just express what the actual URL was. So if it was like, I don't know, openintel.org, and I just had openintel as the name, it would actually translate it out to the URL.
Okay.
There are functions you can do like that with Exchange, but I use Outlook on a daily basis, and it's you can still hover over.
Okay. Okay.
The one thing that, talking about things that change URLs, there are systems like, I want to say Proofpoint, from a like anti-spam, anti-phishing type perspective, where they actually change the URLs or links in emails to be Proofpoint URLs, which goes against the concept of teaching end users, hover over the link, see where it's going. They're all going to say Proofpoint. The idea is everything basically runs through Proofpoint as a proxy, so that way if it is malicious, it can scan it and detect it and block it from getting to the endpoint.
Well, yeah, but it's not going to scan it on the first hit.
Yeah.
So you'll still get somebody to fall for it.
Which is why I'm kind of have mixed feelings about those.
Yeah.
Because I think there's other ones that do it too, but Proofpoint's the one that I know for sure does it.
Yeah.
Just with how they do their URL stuff. But I don't know. I prefer to be able to, hover over it and see where it's going to go. And that's why I hate like tiny URL links, just because they make it to where you don't know. And usually those I'm throwing into a URL expander to figure out what exactly it is before I actually click on it.
Yeah. Yeah. That's why I wish that browsers would, when they detect that you have a location header going off site, it would warn you beforehand and say, hey, it's trying to redirect you here.
Yep.
Yay, nay. Do you want to? But they don't.
I can't remember exactly what it was and whether it was Firefox or Chrome, but one of them was talking about doing something like that, like trying to like notify users more for when there are redirects, when a site's going to redirect them somewhere else. Mm-hmm. Now, I don't know how exactly that would work from a tiny URL perspective. I would think it would still let them know that this is where you're actually going, but
in theory, it should be the same thing, because the way these redirects work is you send the get to tinyURL or whoever, and then it responds back with a 3-something error with a location header, and the location has the URL to redirect the user to.
Okay.
And then user agents can either be configured to respect that and to follow the redirect, or not. Because when I was writing a file retrieval application, that was one of the things that I hit, because it would basically fget or file get the contents of the remote file, including the headers. And I had a bug in it that if you had a location redirect in there, it wouldn't give you anything, because it would just stop on that first page load and not follow the redirect. So I actually had to go back and add in support for following redirects. So,
gotcha.
So yeah, end client applications can certainly know about that, and certainly need to behave appropriately. So yeah, you can absolutely put in code there to do something better.
Yeah, I know there's been a lot of things it seems like Firefox and Chrome have been working on from a like browser security perspective, which is good to see, but we'll see how everything turns out. Because I know there was some features like a month or so ago that they were talking about that I thought were interesting, and I've since forgotten about since we never did a webcast around that time. So I've got the notes somewhere, but I don't know. So moving on to other things that are kind of miniaturized, we'll talk a little bit about a Linux container bug, because we don't often have Linux vulnerabilities that we talk about. So this one was definitely one worth speaking about, and I have a really good Microsoft one later. But so for those of you who are unaware of what containers are, basically, so the idea long time ago was every singles type of server had a physical machine that basically it sat on. So you had a mail server, you had a web server, you had a domain server, you had a file server, and so on and so forth. And then as computing power became greater than the necessity of the applications, and as hardware finally caught up to the software perspective, we started doing more virtualization. So basically you have a single server that acts as a host, and then you can have virtual servers that are running a variety of different operating systems on this host to get basically more utilization out of your processing power and cut down on the electricity used and the amount of pieces that you have that could fail. And moving along that same line came containers, which containers are basically miniaturized VMs, especially from like the Linux side of things. They still run on basically the host operating system's Linux kernel. And then as things are added and pieces of software are added, basically those are run in a container or like a jail type scenario where you can basically have separate, servers that are responding to different IP addresses or so on and so forth, while cutting down on even the overhead of a VM. Now, one of the most common of these is Docker. And I actually use it, but not from a production standpoint. I still have just a regular VM that I have for my production stuff. But from a container perspective, I like Docker because I can spin up a quick development VM in whatever type of environment or whatever versions of software I need installed, which I have an article on my blog about using Docker to upgrade GitLab from an archaic version that I couldn't get upgraded directly on the server to get the instance of GitLab itself and the projects and everything upgraded to go to a new server that actually had the latest version. So it can be very helpful for that kind of thing, but it's also widely used in production for virtualization and stuff as well, which is great.
All I have to say about GitLab is fucking Ruby.
Yes. So it's great, except for when there's the idea behind it is basically everything's contained in this container. I mean, that's the whole concept. But
so there are problems of
problems of.
I'll go into details about the difference between a container, like what we're talking about here, or what you're talking about here, and a virtual machine. Because a virtual machine is a completely separated kind of execution stack that the kernel, your operating system, portrays basically fake hardware, a layer of fake hardware that the virtual machine will access, and everything goes through that layer. So the guest environment has no control, has no access to your physical devices, has no access to the other things running on your computer at that time. It is completely in its own self-contained bubble, if you will. A container goes one step further, and it removes that bubble, and instead it uses the operating system to make a little shell or little environment just for itself, but everything running is running alongside all of your other programs. So the advantage is it's faster, takes less memory, you don't have to have as many redundant applications running simultaneously, you don't have to have multiple kernels running. It's all running on your one base kernel. The downside is that gives you more theoretical attack vectors, because it is running basically as an application alongside all of your other applications. it could, in theory, access the memory from another application or have more access to your physical hardware, things like that. So I'm weary whenever I spin up a container as opposed to a VM. I much prefer a VM because it adds an extra layer of protection.
And one caveat to that, VMs don't by any means mean that you are for sure safe either.
Correct, yeah.
There's actually, I know there's one on VulnHub that's actually specifically for kind of like a proof of concept showing that the host or the VM can actually attack the host. And the whole concept behind it is VulnHub is designed for vulnerable VMs so that you can attack them and learn about security protocols and that kind of thing. But this one's actually designed to, while you're trying to attack it, it's also attacking your host system. So by no means does having it in a VM mean that you're necessarily safe, but it is that an extra abstraction layer of virtualized hardware does make it safer than your typical containers. But from a performance perspective, containers are great. But there happened to be this vulnerability in the Risc-V library, which is used by both Docker and Kubernetes. And Kubernetes, I don't know as much about, but it's designed for like clustering containers. Because one of the big things that containerization is usually directed towards is massive high availability. The idea that you can have IP addresses necessarily don't become as prevalent as they, or matter as much as they used to, because I know with Docker clustering, it doesn't matter what IP the VMs have because they're based off of a name of that VM or that container, that application, so to speak. And then if you take down servers, it basically just doesn't really affect the uptime or performance of it. Now, I don't really do anything with clustering because I don't use it in production. But essentially what this vulnerability allowed it to do was escape that little jail that basically this container's in and be able to, because typically to create the containers and everything, you have to have administrative or root access on the box. Basically, it allowed it to, if you can escape the container, you have root privileges on the host machine. So that was really where the huge problem was. Now, there is a patch for Risc-V, and if you can stop your guest containers from running as root, that's highly recommended. But then again, you also have to consider whatever user they're running privileges as. If they escape, they can execute or gain access. So if you have other containers, they may be able to attack other containers or access data if it happens to be your regular user that's accessing other things. Anything you want to add to that, Charlie?
Nope. Just back to the concept that if you're running an application as root on your box, you're fucking running an application as root on your box.
Yeah.
There are certain liabilities that come along with that. Hell, even VirtualBox, was it a month ago? They had a driver vulnerability.
Yeah, I think it was in January.
Okay. And it wasn't a driver with your hardware, or with your computer, or with anything. It was a driver vulnerability in the emulation stack that Oracle provided in the VirtualBox separation. So it provided this set of stacks that would emulate your hardware. And there was a problem in there that allowed them to escape out from the environment and execute code on the root kernel itself as sudo. Was it as root?
I don't remember.
Okay.
I've bookmarked all those articles. I've decided not to go all the way back to October, but I do want to try and give a rundown from like January stuff because there were some good things that we didn't get to talk about in the last one.
Yeah.
And I try to keep it to just a couple different articles for a one webcast because we've gotten a little crazy in the past. I mean, we've already been going at this for about 45 minutes or so. So
yep.
We've got one more major thing to talk about, but and then whatever else comes up. We're trying to keep the webcast about an hour, and covering every single major security event that happens in a couple of weeks is impossible.
Yeah. And I just have to note that VirtualBox I like to use for development. Docker's okay for production. Fuck LXC. Do not like that container system.
And that's the one that I I'm drawing a blank. What's that? Proxmox. That's what
Yes.
Proxmox uses, correct?
Yes. So Proxmox has two options for virtualization. They have a Xen-based container, which is a virtual machine, a traditional virtual machine. So you can run BSD, you can run Windows, any different Linux distro, because it emulates its own hardware. The more lightweight option, which it is really lightweight and really fucking fast. It boots up in no time whatsoever because it doesn't actually have to start. You basically hit power and you're at your application. It's really cool. But there are some issues where, because it's running as on the guest system or on the host system, certain applications try to access /proc and it's denied because that's actually a privileged file on the host that the guest doesn't have access to because it's a shared kernel, and it can mess up some applications. I've personally had issues with Colab, my email system, because Colab, they try to access something in proc to determine how big your MTU is, and if it's too small, they increase the size of your network card's MTU, or maximum transmission unit. Otherwise, it causes a bug in their program or something silly. I don't know.
Interesting.
Yeah. Well, because they try to access a raw file device that's actually running on a different computer, it gets blocked. Yeah. And there's an exception thrown, and the program crashes. Yeah.
Very interesting.
Yeah.
Yeah, because I've got Proxmox running on a very tiny computer on my desk that I just use the containers just because it's for home use. So I've got a home media server on there. Yeah. I've got a home web server on there, and I've got a home GitLab server on there, and that's it.
Yeah.
But it's fine for that usage. But again, production, I use DigitalOcean, so I just.
And DigitalOcean uses Xen, by the way.
Oh, okay.
So
I kind of figured because I have root access to my VM.
Yeah, exactly. And they wouldn't dare run a container for, tens of thousands of customers across the world. That would be absurd.
Yep, absolutely. So the last thing that I have...
Speaking of absurd items...
Yeah, so as we were talking a little bit earlier about Exchange and Outlook, Exchange had a very serious vulnerability, and it's actually a combination of vulnerabilities. It was just how they were utilized. And of all the things in the security realm, these are the things that fascinate me the most. Probably my most favorite piece of malware that I've ever heard about in the past, Zeus would be second just because of how polymorphic it was, but NotPetya. And it's strictly because of how it behaved. Not only just kind of a little quick NotPetya segment, but basically it was kind of like WannaCry, which WannaCry was the worldwide ransomware that attacked the SMB1 vulnerability using the Eternal Blue double pulsar exploit that was essentially released from the NSA, supposedly. I'm not going to get into that whole thing. But basically, if you're running SMB1 and it was exposed to the internet, that is how it propagated. And even if it wasn't exposed to the internet, if it got into your network through a phishing attempt or what have you, or some other means, it basically scanned for everything on your network for SMB1 and then propagated that way.
Yep.
So NotPetya started out the same way. The difference was NotPetya behaved differently if it couldn't find it, because if in the case of WannaCry, if SMB1 was not available, it didn't do anything.
Which I have to interject real quick. That
Sure.
SMB version 1 was looks like it was added to the Windows for Work Groups 3.1.1 in 1992.
Yep.
And when did WannaCry come out?
2017, I think. Yeah, 2017.
Okay, so
and the other thing to keep in mind is WannaCry was a global security incident.
Yeah. So,
the entire planet was affected.
Yeah. So this virus, this ransomware, was affecting software that had been released 25 years ago.
Yeah.
That was still in production.
And still is.
Even though
There's
they have
still instances of it being available.
Yeah, even though they have multiple releases and upgrade versions better than version 1.
Yeah.
But yet everybody was still running version 1. And why in the hell were corporations why did they need to support Windows 3.1.1?
Yeah. And if you do, you quarantine the shit out of it. Like that's your mitigation step. If it's one of those things that's, you know, a quarter billion, quarter billion, whatever, dollar piece of equipment that has to run, you know, when Windows 3.1 or Windows 98 or Windows 95 or whatever's running under the hood and you can't afford to replace it, yeah, that's understandable. Lock it down.
and by lockdown, you should clarify that.
It should probably be air gapped.
Yes. Don't have it plugged into anything. Have it plugged into the wall for power and maybe a keyboard and mouse. Maybe.
Yeah. There are mitigation measures to try and quarantine that kind of stuff. Even if you does have to have network connectivity, you have multiple layers of protocols it has to get through before it can actually communicate with any other piece of equipment.
Or it's only networked to things that it absolutely needs to. Like the CNC machine it's controlling, and literally that is it. Yeah.
So we're going back to WannaCry, that was pretty much all it did, was attack SMB1. And that's a fascinating story in and of itself. But going back to NotPetya, what I really liked about NotPetya, which also made it even all the more horrifying, was if it hit SMB1, couldn't find it, couldn't do anything, rather than stopping, it started trying to utilize other measures on the local system, such as dropping Mimikatz, pulling all the file hashes, and seeing if there was actually like local admin. For one, if it had local admin or non-local admin, it behaved differently. So if it had local administration on the machine that it was sitting on, it encrypted the entire disk.
Makes sense.
And so it was full disk encryption that it was utilizing for the ransomware. If it didn't have local admin, then it just basically acted like normal ransomware and encrypted all the files that it had access to as the user was running as. Mm-hmm. But then it basically, if it could find like a local administrator account, it would scan around and try and use PSExec or WMI to actually propagate to the other systems. And the reason that was such a threat is a lot of the times when companies build computers, they have a standard local admin account they use when they set them up and they deploy them. And unless you deploy something like LAPS, which is local administrator password service, to where it actually changes that and it's unique per machine, then it doesn't matter if that user is an administrator or not, the user that initially got infected, because it can use that local admin account and affect every single other system on the network if that account's present. And in most cases it is, unless somebody's implemented something like that.
Yep.
So it was using more of like a intelligent method of problem solving to spread and infect systems, which makes it more of like, I think they determined at that point it was a nation state level attack, which shows the level of sophistication because it actually was directed towards the Ukraine. But without going any more into that, those are the kinds of attacks that fascinate me the most.
As a programmer, I'm saddened that you said that. Like, to me as a programmer, that is only your basic, operational procedure, is that you try this, and if it doesn't work, you catch and try something else, and you go down your steps of what you need to do to accomplish what the program needs to do. And if you don't, then you're probably a junior developer or an intern, and you shouldn't be writing production code in the first place. So the fact that all these ransomwares are using junior grade development, it's just sad. Like, for the developer who wrote them. I mean,
well, usually they're going for the broadest realm of infection with the least effort possible. If you can get away with a single line of code and take out 100,000 systems and make $50,000, $1 million, whatever out of it, that's all they're after. And it doesn't matter how crude it is. And there's been actually like simplistic things that people have done with malware that malware authors have left in, like their LinkedIn URL or something stupid like that. So these people aren't necessarily thinking everything all the way through. They're just going for the shotgun approach. And whatever they hit is fantastic. Whatever they miss doesn't matter to them.
Hey, here's my LinkedIn. And if you want to send me an SMS, here's my phone number. And if you're in this area, this is my house address. Come pay me a visit. Smoke some hashish.
I mean, they make it easy for the malware analysts and law enforcement to resolve the issues. So it does happen. But occasionally you come across something with such level of sophistication that, as dangerous and terrifying as it is from a like defense and blue team perspective, which is what I normally fit into, I'm only kind of playing around with the offensive side of things. To actually see something like this, is like horrifying as it is, it's absolutely amazing the level of sophistication that went into the attack, as opposed to what we normally see, which is that, you know, LinkedIn infect all of your doc files, whatever.
Yeah.
So,
Sadly, in this profession, that mindset is not contained exclusively to malicious actors.
yep.
Many corporations, especially some of the biggest corporations who write software, have the same mindset of, well, what's the least amount of effort needed to get money?
Yep.
Which in that case, it's legal because they're, you know, a legitimate business, but they still follow the same mindset. Like, okay, what's the least amount that we can pay our developers, and what's the least amount that they can work to achieve this purpose? And if it technically works, great, ship it.
Yep. So going back to the vulnerability I was talking about. So there was actually, it was like a layered attack. And there was a proof of concept, and Tyler will bring up the link here in a second. But so Exchange has, by default, if you just set up an Exchange server, and Exchange is Microsoft's mail server, if you're not familiar with it. So by default, it has too high privileges on the domain. And the domain is your Active Directory connection. That's basically how all your computers connect and communicate with one another using the same username and password, same computers, being able to rotate around between computers with users and whatnot, and have everything behave as you would expect. Whereas, you know, differently going to, you know, a different home computer or something, which most people don't have a domain at home. So by default, an Exchange server is set up to have way too high of privileges, essentially domain administrative level privileges, which was the first issue. Now there are mitigations that kind of make this null and void if you actually follow the best practices recommended by Microsoft of limiting this and essentially having Exchange administrators and then domain administrators. But a lot of places don't want to do that because they don't want two accounts for the administrators. Then NTLM authentication is vulnerable to relay attacks, and this is kind of an NTLM issue. But it's another vulnerability that Microsoft has. And NTLM is the hashing algorithm used by pretty much everything Microsoft related, and it's extremely easy to crack, which is why things like Mimikatz and stuff are so effective, because if they're stored locally on the machine, these can be used to determine the passwords very easily of user accounts that are signed into that machine. And then lastly, Exchange has a feature which makes it authenticate to an attacker with the computer account of the Exchange server. And this has to do with Exchange Web Services. And then this article kind of goes into a lot more depth on a technical level of basically how exactly the attack works. But essentially, by combining all three of these vulnerabilities in a new fashion, kind of like what I was talking about with NotPetya, utilizing different steps and things to escalate it, somebody can compromise a standard email account, and by doing that, gain domain administrative level privileges in the domain. The reason this is such a big concern is most Exchange servers are exposed to the web or the internet because people want to be able to check their email when they're outside of the office. You want to be able to check it on your phone. You want to be able to check it on your home computer, or, dear God, not at the cafe, using one of their kiosks or the library, but some people do. Or, you know, that terminal at an airport in the middle of China that's, you know, perfectly safe to use, I'm sure. So people want to be able to check their email. I mean, that's the whole idea. We're very, from a business perspective, we're very interactive with what's going on in the daily business. I know I have my email on my phone. I check it regularly from home. It's on my work computer, but still, I want to be able to check it when I'm outside of the office, as does anybody else that's in a professional type role where they interact with business email. So by exposing that, it exposes the risk of an attack. In this particular instance, that means everybody that has email in your organization, their accounts could potentially be used for this attack. Now, typically your domain administrators don't have email associated with your domain admin account. Hopefully not anyway.
Well, they kind of do, because if they have a user account, then Exchange will gladly auto-create their inbox.
Correct.
Yep.
But, actually, you can actually set it up where they don't have...
You could, but
yeah.
is it set up by default?
I'm not sure.
Yep. And by the way...
I haven't been in that process, honestly.
Yeah. And by the way, this segment brought to you by OpenVPN. Not really, but might as well be.
Yeah. Always use a VPN when possible when you're not at a trusted location such as home or work.
Yes.
But going back to this, the attack, so most of the time, even if you do have, hopefully your administrators have very strong passwords. We're not going to go into the fact that most of them probably don't, but hopefully they've got, 16 to 32 character passwords at least, and it's not going to be an issue. Maybe they have multi-factor authentication and stuff set up for the administrative purposes. The problem is because of how this attack works, it only requires you to be able to authenticate to a regular mailbox. How many users out there do you think have something like password 1 as their password, or their significant other, child, or dog's name, and then a number, like their birthday, or something of that nature? These weak passwords, and if you don't have multi-factor authentication, which I have another segue on that one here in a second, if you don't have multi-factor authentication set up, then essentially they can authenticate with that user, perform this relay attack, and because of Exchange's high level of privilege, be able to gain a domain administrative access to your devices on your network. So huge concern there. Some of the mitigations until this patch, because Microsoft does actually have a patch. They released it this past week. But it is a cumulative update, and cumulative updates for Exchange are rather time-consuming. So it does require a couple hours of downtime to actually achieve the proper fix from Microsoft. But the mitigations were having the separate Exchange and domain administrative accounts, separating that out. That kind of mitigates everything. But the other really thing that you could do was turning off Exchange web services, which breaks lots of remote access, such as phones and whatnot. So a lot of organizations probably just accepted the risk and hoped that it didn't happen. The segue I was talking about regarding turning multi-factor authentication on. So this came up. I was following another discussion, and I haven't found the blog article yet because I don't know the person's finished writing it, but they were talking about it in one of the InfraGard channels that I'm a part of, where I guess when EWS authenticates, it bypasses any multi-factor authentication. So even if you have it set up for Exchange and that kind of thing, Exchange Web Services doesn't follow that. So even if you have, extra layers of security in place to try and prevent an account breach, Exchange Web Services kind of bypasses all of that, and it doesn't matter what you have in place. The only thing that matters is the password, which is just awful. Yeah. But yeah, Microsoft has released the cumulative update. Oh, and the other thing is this impacted Exchange servers that were 2010 or newer. Originally, it was released as saying 2013 or newer, but they actually released a cumulative update, Microsoft did, for 2010 as well, which tells me that it's not just 2013 and newer. They found it in 2010 as well.
Yeah, so it sounds like the attackers were just testing or just located it on 2013, and Microsoft thought, oh shit, this same library is running in 2010 also. Which, kudos to them for noticing that and backpatching it.
Yep. Yeah, because Exchange 2010 and EOL's, I believe, next year, either this year or next year.
Yeah.
But yeah, if you go back to that Dirt Jam, whatever that website was with the initial disclosure, if you scroll down to the tools affected versions, so he did a POC, excuse me, on Exchange 2013 CU21 on server 2012 R2, relayed to a server 2016 domain controller, and these were all fully patched. That's the thing to keep in mind. These are all up to date on the latest patches. Then also Exchange 2016 and Exchange 2019, tested on both of those on server 2016 and 2019 DCs. So it really didn't matter what, and based off of Microsoft's guidance, it didn't matter what level your domain controller was. You could probably have a 2003 domain controller and it would be vulnerable. But as long as it was Exchange 2010 or newer, you were vulnerable to this vulnerability. So
looks like they're making a SOAP post request to EWS.
Yeah, it's an API call that essentially grants them deity level.
Yeah. Well, that's nice. They even have command line arguments that provide help support for the attacker to know what commands to run. That's friendly of them. That way you just run tech help on this attack and it tells you all the options. And awfully nice.
Of course.
And it has full logging set up using the default Python logger or logging library. That's nice. That's a really nice utility. And you can configure the port, so if the admin tries to be clever and like, oh, nobody's ever going to try 4443, you can just set that. That's nice.
Yeah. Scan it, find out based off of headers that it's an Exchange server, and scan all 65,565 ports or whatever the hell it is.
Which usually takes about 40 seconds or so.
Yeah, maybe with Nmap, but if you're using like mass scan, it'll take probably
true.
5.
Well, no, mass scan is great for multiple hosts.
That's right. Mass scan's the one that's if you're scanning the entire internet's fast.
Exactly. Yeah.
It and Zmap.
Yeah, but if you're checking one particular host, doesn't really matter.
Yeah, Nmaps.
Yeah.
I was thinking there was another one that's extremely fast for scanning a single host.
Well, there are options that you can send to Nmap to.
Well, yeah. You can make it extremely aggressive and kick the box over.
Yeah. I don't know what commands you're talking about.
I may or may not have done that to some old Windows servers in the past.
Get a call from a client. Hey, my box isn't responding. Oh, shit. Okay. Is it working now? Oh, must have been just a fluke.
The other day, I was running OpenVOS against a semi-production device that I had recently set up. It was a switch that I had TechX recently set up on. Yeah. And it's semi-production as in like there's only a handful of it's like a dev environment that's running off of it. Oh, okay. It's nothing actual production, but it is actually being used outside of just being a test switch.
Right.
And I usually have our NAC up on the one screen, and I started scanning that switch with OpenVOS, and then all of a sudden, out of the corner of my eye, I just see all this red showing up. And I'm like, what the hell's going on? And I'm like, oh, that's me. Because by default, when I'm trying to check for default credentials, it tries all of them.
Yes.
And they all get rejected by TACX and get alerted into the system.
Well, that's good.
Yeah. Yeah, it was nice kind of seeing my alerting capabilities because that was on the fly.
Yeah. And OpenVAS, by the way, is a kind of boxed solution for scanning your network and devices. And it is extremely effective at locating vulnerabilities, locating potential problems and actual problems. But it does take a literal IP shotgun to the host. And if the host isn't powerful enough to withstand it, it's going to fall over.
Shotgun might be a bit of a understatement, more like a minigun.
Okay, yeah, minigun grenade launcher.
Yeah. The other thing to point out. So, Nmap is a network scanner. So it's scanning for ports, protocols, devices, whether or not they're up. It gets banners, that kind of stuff. There's a lot more you can do with the scripting engine. But by default, it's basically just trying to get you information, not necessarily passively, but not intrusively about the host.
Well,
in the same way, basically, that you're interacting with it by going to the web page and actually loading it up, or trying to check and see if TCP, I don't know, see if SSH or something's running on it. That kind of thing. It's just basically checking it without. It does it very quickly, which is what can cause certain systems to lock up. But it's not really invasive. OpenVOS, on the other hand, is an actual vulnerability scanner. So it's actually checking for vulnerabilities that exist in applications. So say it is SSH? Is it SSH version 1? And if so, what are the exploits that are available for that? And it will check and see if those are present.
And it actually runs the exploits against them to verify that what it thought it might have as an issue is actually an issue.
Yep.
Yeah.
So frequently it will just basically get stopped right in its tracks if you have something like fail to ban or something like that set up. So when it does try, multiple usernames or passwords, it just blocks the IP that it's originating from. So it gives you false results. You have to usually whitelist it if you're testing it, past protections like that. But because of that, you don't want to scan critical systems that are in production because you can easily break them.
Yep.
I have taken down many a system with OpenVOS, fortunately not in production environments. So, yeah, and that goes with any vulnerability scanner, whether it be Nessus or Qualys or what's the one from the people that Rapid7? What's theirs? I'm trying to remember. I can't remember off the top of my head.
Me neither, but luckily we have DuckDuckGo.
Expose.
Yeah.
Yeah. So, yeah, we kind of trailed off there, but
Documentation not found. Oops. Oh well. Yeah, the worst thing to hear when you're setting up a scan of somebody's network, of a customer's network, is you bring up these concerns of, oh, okay, we have these scanners that can potentially cause damage to your network. So let us scan your staging environment, like your stage environment, and we'll test that. And the client comes back to you, stage? No, we don't have stage. We just have production. Like, is that good enough?
Yep, and then what normally ends up happening is you are given blacklisted hosts that you're not allowed to scan. And while they are probably mission critical and you don't want to take them down in production, they're probably the ones that are also not being taken down for patches and probably have the most vulnerabilities that need the most attention.
Yep.
And I was actually having a conversation with someone the other day talking about, these critical systems that people just don't take down. And while typically they're like, we need 2 hours of downtime. Well, we can't give you 2 hours downtime to, update the OS or whatever the case may be. So rather than, it's too important, excuse me, trying to figure out how exactly he phrased this and how I can rephrase it. Essentially, rather than telling them, we need to do this because of it's a risk and they say, no, we can't. The response to that is, well, because it's so important, we have to get this downtime. Because if we don't take it down for 2 hours to fix it and fix these vulnerabilities, an attacker could take it down permanently or for months, days, hours, weeks. Who knows? Depends on how much damage they do and what the exploit and vulnerability are. And whether or not they get persistence on the device and, keep coming back and wrecking all kinds of crap.
Yep.
Or, propagate throughout the network and then you have even more problems.
You see, if they're running Linux, many Linux distribution providers provide something called live patching.
Yep.
Red Hat provides it. Oracle provides it. Canonical provides it. And Novell. Who bought SUSE? Does Novell still own them?
I don't know.
Oh.
I haven't looked at SUSE in a long time.
Okay. But they support it too, where they can update the base operating system, like the underlying lowest level software running, without a reboot. And they achieve this by swapping out the kernels running in memory with the upgraded version in memory. So,
I always wondered how that worked.
Yeah, so it's kind of a cool idea. Now, they need to know exactly what version of the module, of the kernel you're running, because it needs to know exactly what part of the memory to overwrite and exactly what size and all that good fun. But yeah, it, from what I've heard, works pretty well, and you can update literally everything on the system without taking it offline.
So usually when it comes to my Linux servers, I just reboot them because it takes like 30 seconds worst case scenario for it to come back up.
Yeah.
Windows might be 30 minutes on a good patch.
Yeah. Yeah. Yeah, I've been working on an auto update tool that will let me control multiple devices and install updates to them from a central platform. And yeah, it's funny. All of my Linux hosts that I've tried, experimented with, like, oh, patch deployed. Great. Nothing else. The Windows hosts, I'll just see it like restart 5 times. I'm like,
that's the other thing. Half the time, Windows has to restart multiple times to do an update.
Yeah. Like, I hope that was intentional and wasn't caused by my fuck up.
Yeah, you don't want to actually like pull up the console view and see reverting to previous version on the screen.
Yeah. I've seen that a few times.
So have I.
Maybe one of these days they'll figure out their shit.
They've gotten a lot better. I think as they get closer to using Core strictly instead of or in that Core, what the hell do they call it? Is it Core? Microsoft Core? Server Core? I think it's Server Core. I don't remember.
Server Core is just the command line or
it's basically just PowerShell.
Yeah. That doesn't affect the kernel though.
No, but it probably cuts down on a lot of the overhead required for loading shit back up.
Hopefully.
I have not actually had the pleasure of working with any Core servers. They've all been GUI based, which drives me nuts from an administrative standpoint. I've gotten so used to administering things. Network equipment is all, CLI. So Linux servers are all CLI, hopefully. So,
but have you actually tried to administrate a Windows server with just the command line?
No. I would like to learn. I'm sure if you're good enough with PowerShell, it's not a problem.
Yeah. But see, I have a major problem with it.
Yeah.
Because I can run, Python, I can run Bash, any of those, pretty easily. And
I just install PowerShell on my desktop, which is, Mint.
I actually have PowerShell running on my local box. Yeah.
Yep.
I
haven't done anything with it yet, but I was like, this is cool.
Well, you can't do anything.
Something I had to do when I installed .NET, and then I just installed PowerShell.
Yeah, you can't do anything with it because all of the commandlets or whatever they're called.
Yeah, commandlets.
Are proprietary Microsoft property. And while they've provided the interpreter for PowerShell, they didn't actually provide any of the scripts that you need to run to actually make any use of PowerShell. So I can load up a PowerShell shell on my Linux box, on my Debian box, but it can't do anything.
You can LS. That's the only thing I actually messed around with. I started PowerShell, did an LS the folder was in, was like, cool, and then exited.
But that's my problem with PowerShell and managing Windows servers from the command line, is that it's not just a command line. Yeah. It's a C# programming language that interacts with compiled COM objects and DLL objects. But that's not command line. Like, they completely missed the ball on what IT admins wanted from a command line of being able to execute simple commands to achieve a single small task. Like, we have access to the Win32 COM object stack and WMI and all that, but they're not, they're full objects. They're full DLLs. We don't just have single simple commands that we can run, which defeated the purpose.
Yeah, most of my experience with PowerShell has just been specific things that I really needed to do, and usually a lot of times outputting stuff to files. That's the majority of the kinds of stuff I've really done with PowerShell.
Yeah.
There's certain things that just work better that way. Otherwise, most of the time it's easier to just point and click. Yeah.
Like even a watch, or you run tail on a file to watch the output of the file.
Yeah.
Tail TACF. On Windows, there is no equivalent. You do
I know, and that drives me nuts.
Yeah, you get content, tac wait, and then give the file name or something. But in my experience, it didn't actually work very well.
No.
So the solution is to just open up Notepad and then keep reloading the file.
Assuming that it's a small enough log file that Notepad can handle it.
That too, yeah.
I usually find myself opening it up in WordPad or VS Code. VS Code seems to do pretty well. I was the other day, I was actually looking at a 40 meg log file, which just makes Notepad explode. But VS Code worked fine, and I was able to find exactly what I was looking for. And then I took that section and then pasted it into Notepad so I could look at it a little bit better.
Yeah. So until they realize that IT admins need these tools, command line's not going to be very helpful.
Yeah.
They kind of over-engineered it.
Yep.
Missed the mark a little bit. But it'll all be resolved when they drop the NT kernel and switch to the Canonical's Linux kernel in a year or so.
Is that a for sure thing?
I'm expecting it to happen, yeah.
Really?
Yeah.
I know they have been getting really close to Canonical.
Yeah.
Really close.
Like the new version of Windows 10 ships with SSH enabled by default.
Yeah, I know, which is very handy for somebody who is in a Windows environment and likes to get to their Linux servers. Because I also have Git Bash installed, so I just use that 90% of the time whenever I need to do anything.
Yeah, and all the tools that we know now work with a simple just enable option. So it's... And most of their .NET library works on the Linux kernel. So they're not far off from just dumping Win32 completely in favor for their Win32 compatible libraries.
And then the games for Windows won't matter anymore.
Kinda.
Well,
yeah.
Kernel architecture, I would think, would resolve that problem.
No, not entirely, because they're still going to have their libraries that only they control, like for DirectX. They're not going to allow DirectX to run on Linux because that would be silly.
Which they don't have DirectX now. The new one is like, I don't know. It's something really weird because every time I am browsing through add remove programs, I find it and I'm like, what the is this? It's like Falcon or some shit like that.
Vulkan.
Yes, Vulkan. There you go.
They're switching to Vulkan.
Yes.
Oh, fuck yeah. That's awesome.
Yeah, Vulkan is actually the replacement for DirectX because I've seen it on a lot of Windows 10 systems. I didn't realize that was a thing outside of the Windows world.
Guess what's native on Linux? Vulkan. So yeah, if they dump DirectX in favor of Vulkan, gaming
which
will
I think
be solid.
they're doing.
Yeah.
Nice.
Because Vulkan's first candidate, first priority, it runs natively on Linux. So as long as they're supporting the standard Vulkan API calls, that'll be great. Nice.
Well, it's been about an hour and a half that we've been broadcasting, and it's close to midnight, so I have to work in the morning. So probably should wrap this up.
This other post that you sent me. So we have Dirk Jamen, and then something from Bleeping Computer. Is that the same thing?
Yeah, that's just talking. Yeah, it's same vulnerability. It's just talking about where Microsoft released the patches to resolve it.
Oh, okay, I see.
Yep. Just figured it's something else to link in the video.
Okay, cool. I will send that link in the release notes, and we'll be good. And we'll actually have kind of release notes for the post for the first time.
Yeah.
I may have done that before, but yeah.
Yeah, I think normally you post it after effect in the description. So
yeah. Yeah. And also, before we leave, I just need to make a quick note that the intro music I found on Incompetech. Competech? I don't know. I'll set the link in the description as well. They provide royalty-free music for anybody to use. Like, seriously, it's free to download, free to include in your videos, and hopefully, fingers crossed, I won't get hit with a ban notice like I have before. And if I do, I'm very liable to say just fuck YouTube altogether and go somewhere else. Because this is getting silly.
We'll start our own streaming service. The Blackjack.
Blackjack?
Have you ever watched Futurama?
Yeah.
That one scene that's been referenced God knows how many times where Bender gets pissed off about something and he's like, I'll go start my own whatever with blackjack and hookers. You know what? Forget the whatever.
Nice. Yeah.
Yeah.
I feel blackjack.com might already be taken, though. So
probably. But yeah, so hopefully we don't have any issues with that. But it was kind of cool to have a theme song.
Yeah. Now we just need to get a better intro video or picture or something, and it'll be good.
We'll come up with something.
Yep. So until next week or the next time that we do post, or who the hell knows? I don't know. Stay safe.